This video is going to work on finding exact values of a trigonometric function when they occur in more than one quadrant. So for example here, I say find all of the values of theta between 0 and 360 degrees for which sine theta equals 0.45312. They want us to round theta correctly to 2 decimal places. Well, the first thing I'm going to do is I'm going to actually find what angle this ratio gives me. So to do that, I'm going to say sine theta equals some ratio, 0.45312. Now we already know how to solve for theta here. To solve for theta, I need to take the inverse of sine, so it's on the other side here. So I get theta equals, and then I have my inverse of sine of that ratio, 0.45312. And this is going to give me some angle. Okay, we're working in degrees here. So I'm going to plug that into my calculator and see what I get. Okay, so I have my calculator up here. And I'm going to take the inverse of sine, or kind of like saying second function sine, 0.45312. So I want the inverse of that. The inverse sine, that gives me an angle of 26.9, or for our purposes, we're going to say 26.94, because they say to 2 decimal places. So what that means is that when sine is equal to this ratio, I get an angle of 26.94, and that comes out of our grade 10 math, so we've seen this a lot. Now the problem that comes about in pre-calculus 30 is we have 4 quadrants to worry about, and in each quadrant the values are different based on our CAST rule, C-A-S-T. We can see that sine is positive in not only our first quadrant, but our second quadrant as well. So I wind up with 2 scenarios happening. I have one scenario in my first quadrant where my value is 26.94 degrees. But also because sine is positive here, I have an angle showing up in my second quadrant. And my 26.94 is my reference angle here. Okay? So one of my answers, I'm going to wind up with 2 answers here. One for this red line, one for this red line. One of my answers is simply 26.94 degrees. So we could say theta equals 26.94 degrees down here, and it's going to equal something else. That something else comes out of your second red line. Okay, so I've just erased our first quadrant here, just so we can remember we're only working in our second quadrant. Now, I can't say that this angle is 26.94 degrees, because that's my reference angle. That is not in standard position. Standard position angles always start from 0 degrees, or your furthest right-hand arm, and move counterclockwise. So what I need to do is figure out what this angle is in order to get my second value here. Well, we know that this total angle along the straight line is 180 degrees. So if this whole angle is 180 degrees, this purple angle, or my standard position, is going to be 180, take away my 26.94 section. So my purple angle right here comes from 180 degrees minus 26.94 degrees, minus my reference angle. When I do that, that gives me an angle of 180 minus 26.94 degrees, 153.06 degrees. So that means our second angle here is 153.06 degrees. So we're going to wind up with two solutions because, remember, based on my cast rule, just going to draw a new set of quadrants here. Maybe one that's actually two lines. So here's one, and here's a second. So remember that based on your cast rule, the variable, the letters, tell us where something is positive. So cosine, all, sine, and tangent. Since we're looking at our value of sine as a positive, that means that it's going to occur either in my first quadrant because sine is positive, or in my second quadrant because sine is positive, meaning that I have two solutions of 26.94 and 153.06. Okay, quickly we're going to go through one more example that involves secant as well as a specific domain between negative 180 and 180 degrees. So our first step is the same as before. We need to figure out what this actual angle is. So I have secant theta equals negative 4.25889. Well, secant, you will recall, is the inverse function of cosine. So I could actually rewrite this as 1 over cosine theta equals negative 4.25889. And just to be thorough, we're going to write that over 1, because then I have a fraction on each side. But I don't want to solve for 1 over cosine theta. I want to solve for cosine theta. So what I'm going to do is flip both sides. So I could rewrite this as cos theta, and then on my right hand side I'll get 1 over negative 4.25889. So let's plug this in and actually see what value we get for a function there. Cos theta equals a ratio of, so I get a value of 0.234803, and that is negative. Okay, and I want to know what cosine is of that, so I'm going to take the inverse cos to the negative 1 of that function, of that ratio is negative 0.234803. And when I plug that into my calculator, I get an angle of 103.58 degrees. Okay, so that says, if I look on my quadrant, that the cosine value of this angle is going to be right here, 103.58 degrees. But we know, again, based on cast, C-A-S-T, that cosine, which comes from our secant, is negative not only in this quadrant, but also in this quadrant. So what I need to know in order to figure out this little angle right here, this little guy, is I have to find my reference angle, which, remember, is always in between your angle and the x-axis. So what I'm going to do to find this section, same thing as last time except the opposite. This is 103. This is what I want to know. This whole thing is 180. So I take 180 minus 103.58. And that gives me 76.42 degrees. So I have a reference angle of 76.42, which means this angle right here is also 76.42 degrees. I will not get a value in here because cosine is positive. I will not get a value up here because cosine is positive. Secant is related to cosine, so I'm looking for where cosine is negative. So one of my answers is in between 0 and 103.58 degrees. That falls within my domain. This is my first answer. Now my second answer has to be in between 0 and negative 180, because my domain this time is not from 0 to 360, but it's from negative 180 all the way around to positive 180. So that means that I'm now trying to find from 0 to negative 180. So I want to know this angle right here. Well, again, I know that this whole side is 180 degrees. I know that this angle is 76.42. Well, based on what I've done up here, I can say that this is 103.58 degrees. But it's going clockwise, which means it's negative. So I still wind up with my two solutions for theta here, but they are positive and negative 103.58 degrees. So just remember, you need to check if you have more than one solution based on your domain as well as your cast rule.